so yeah, we're doing page 318, numbers 28 through 31 first. Number 28 on page 318 looks like this. So we got x squared minus 30x minus 64 equals 0. There were a few people who asked about this one in class. So of course, the quadratic formula will always work. But if you did the quadratic formula on this one, you're going to have a bad time because opposite of b plus or minus the square root of b squared minus 4ac. Holy cow. Like, over 2. No, like, just don't do that. Never do that ever, please. I mean, okay, maybe do it if it's the only option. And if you don't want to think too hard about it, you just want to do math, sure. Go ahead and do 900 minus 256. You just go right ahead and do that. But I'm not going to, wait, minus? Plus. But the point is, just don't do that. Instead, what you want to look for are certain shortcuts. For example, knowing that there's like, a is 1 here, it may be possible to break this down into an x something something, x something something. And that's the technical way to say it. And that means that I'm looking for numbers I could put here that have a sum of negative 30, but have a product of negative 64. Having a product of negative 64 is really very lucky because 64 is part of an illustrious group of numbers, the powers of 2. 2 to the 0 is 1, 2 to the 1 is 2, 2 to the second is 4, and this continues on until, that's, hold on, being blocked by this, there we go. Yeah, that goes on until that one, which means it would be nice if one of these numbers, 1, 2, 4, 8, 16, 32, and 64, might end up here. So basically, are there any two numbers here which either add or subtract to make 30? And the answer is yes. We got 2 and 32. So if this were minus 32 plus 2, minus 32 and plus 2 multiply to make negative 64. Minus 32 plus 2 equals negative 30. That's a great way to do it. They have to give you some sort of weakness in order to make the problem solvable. If they don't give you a weakness, you just have to nuke it with a quadratic formula. The point of this exercise is to look for, I don't know if shortcuts is the right word, but is to look for ways to break the problem down rather than, again, having to nuke it. So if that equals 0, then the solutions are x equals 32, because when x equals 32, that becomes 0, or negative 2, because when x equals negative 2, that equals 0. That's the idea. Now, I went all out on that one. I think I might have to be a bit more brief with the others because I do want to fit all those in. So let's go ahead and do number 29. Number 29 looks like 7x squared plus 3 equals 0. Now, the simplest possible problem would just be x squared equals something, and then you can take the square root of both sides. You can't do that with this because there's an x in the way, and you can't just square root that. However, this one doesn't have an x, and that means it is possible to get x by itself. And you do it like this. Minus 3 on both sides. You got 7x squared equals negative 3. Divide both sides by 7, and you've got yourself x squared equals negative 3/7. If this were Algebra 1, we would be done and we would say no solution, but really in Algebra 2 we can say no real solution. If you take the square root of both sides, then you've got yourself an answer. X is equal to the plus or minus square root of negative 3/7. The thing is, those are not real numbers. But that's okay. The fact that they're not real is no more mysterious or scary than they're not whole numbers. If you were to try to simplify it, you wouldn't have any luck because 3 and 7 are both prime. About the only thing you could do was take the negative sign out and make it this. I root 3, 7 and minus I root 3, 7. But like, honestly, is that any better at all? I don't know. I don't think so. I think these are equally evil, and maybe that you can just do less work and do that one. But I just want to make sure that you know that there are steps you could take. It's just not necessarily certain that you should take them. Because, I mean, again, I don't really know if these are an improvement on that. That might just come down to preference. Anyway, number 30. I don't know if I can fit it in this space. I will try. If I can't fit it, it'll just carry on to another sheet of paper. So number 30 is x squared minus 4x plus 7 equals 0. Okay, so if this were factorable like the first one, there would be some numbers that add to make 4 and multiply to make 7. Unfortunately, the only numbers that multiply to make 7 are 1 and 7. So that's not going to work. If we were to put this in vertex form, we could complete the square, and that would be good, except that completing the square doesn't help us solve for 0. It only helps us find the vertex. If the vertex isn't on 0, then there's really no help here. So in the absence of an obvious shortcut, I'm just going to do the quadratic formula. The quadratic formula, again, being like that. Opposite of b plus or minus b squared minus 4ac would be 4 times 1 times 7. Oh, that's why it's not factorable. See? B squared minus 4ac over 2a. So 16 minus 28 is 12. Negative 12, isn't it? Negative 12. All right, so this is 4 plus or minus the square root of negative 12 over 2. This is simplifiable. So let me show you how. Negative 12 is equal to negative 4 times, or I should say 4 times negative 3. So I'm going to write this over here just because I need to make good use of space. 4 plus or minus negative 12 is 4 times negative 3. Okay, so that's 4 plus or minus the square root of 4 times the square root of negative 3. See what I'm doing there? The square root of 4 is equal to 2. So if I cancel out a 2 on the top and the bottom, I've got 2 plus or minus the square root of negative 3, which again is the two numbers, and you can decide whether you think this looks better. 2 plus I root 3 and 2 minus I root 3. It's like, it's like broccoli and cauliflower. It's just whichever one is less disgusting to you, choose that one. I don't know, I kind of like broccoli. Anyway, that's 28, 29, 30. Now I need to do 31. Then I can move on to the other page. So, number 31 on page 318 is 2x squared plus 6x minus 3 equals 0. So, part of the problem when this is not 1 means that if you tried to factor it, you would end up with, well, here, it looks like this. In order to get 2x squared, here's your options. It could be 2x something something x something something, or it could be x here and 2x there. But since it's reversible, I guess that'll just have to do. Now, in order to add to make 6, it has to be double of something plus single of something. I say double because whatever is here will be multiplied by 2x. So just by example, if these were both 1, I'd have 2 times 1 plus 1 times 1. So really, the key here is -3. There's only 2 ways to get -3. -1 times 3 or -3 times 1. So there's only 2 options. It's either -1 times 3 or -3 times 1. And the question is, are either of those correct? Because if not, there's no way to factor this. 2x times 3 is 6x. That's promising, but -1, no, that's only 5. Sorry, this is 2x squared plus 5x minus 3, and that makes everybody sad. This one, 2x times x, that's 2x squared, but it's plus 2 minus 3, that's minus x minus 3. And now, I'm not even sad anymore, like I'm mad. So neither of these work. So this can't be factored. Again, putting it in vertex form won't help us find 0. It'll only help us find the vertex. So there's really nothing else to do but the quadratic formula. By the way, if you were to graph this and see that the x-intercepts are not on whole numbers or simple fractions, you probably could have just given up on that search and just went for the quadratic formula. Opposite of b plus or minus the square root of b squared minus 4ac. That's 4 times 2 times 3. 4 times 2 times 3 is 24, but that's negative, so it's minus -24. Hooray, finally, it's not imaginary. All over 2a, 2 times 2 would be 4. So 36 plus 24 is, let me see here, that's 3 12s, that's 2 12s, so I've got 5 12s up there. That's 60. -6 plus or minus the square root of 60 over 4. 60 does have a square as a factor. It's divisible by 4, which means that this is equal to -6 plus or minus the square root of 4 times the square root of 15. That square root of 4 is equal to 2. So if we cancel out the 2, we've got -3 plus or minus the square root of 15 over 2. That's the answers. It is -3 plus root 15 over 2 and -3 minus root 15 over 2. Yeah. So just to make sure that we're clear on this, this does have 2 real answers. But if we were some sort of weird genius who is capable of factoring it, this is what we would have gotten. 2 of x minus that times x minus that. This is why you can't factor things that you have to use a quadratic formula to get irrational answers. Because if that makes you sad and that makes you mad, this makes you dead. So we're just not going to do those. Use a quadratic formula if this isn't easy, okay? Once you start trying this and it starts giving you more difficulty than it's worth, just bail. Just bail. Just go to the quadratic formula. The entire point of this is to help you avoid that. But if this is impossible or worse, then, just embrace the pain and go for it. So the next set of problems that we're going to do is on page 326. I'm going to try to do 15 through 18 right now. We're looking good on time. So I'm going to move that aside because I'd like to keep them somewhat in order. So here we go, page 326. Right now I'm going to start with number 15. So the equation is y equals -2 of x plus 3 squared. The instructions say to write each one in vertex form if not already in that form. Just to be clear, here's vertex form. Once it's in vertex form, then you just need to identify the vertex. That would be the point HK. The axis of symmetry, that would be the line x equals h. And the direction of opening, and that's basically just if A is positive, then it's a smile. And if A is negative, then it's a frown. By the way, if A were 0, it's not a parabola. Yes?
So, would you say that if A is less than 0, would that be downwards?
Yes, I would call it downwards. Smile and frown are just me being goofy. Yeah, those are definitely not technical terms.
Because, and if you look at the, that goes downwards when...
Yeah, exactly. The way that those are referred to in calculus, because you do need to do an analysis of what direction things are pointing, this is called concave up, and that's called concave down. But yeah, opens up and opens down. That's exactly right. Anyway, this is already in vertex form. If you will think of this as being plus 0. Therefore, k is equal to 0. So it's already in vertex form. We can say that the vertex HK would be -3, 0. This is really important, okay? Vertex form has a subtraction here. So if that says x plus 3, that's x minus -3. So I suppose if we're being really picky, this would be the real vertex form, -2 of x minus -3 squared plus 0. I mean, I think that you could be forgiven for calling that vertex form. I mean, I did just a minute ago, but if you don't want to have to get tripped up on negative signs, you might as well go all out and say, no, I don't care what it is, it's got to be minus. So if that were the case, our vertex, I love that word, vertex. The vertex is the point -3, 0. -3 is in the place of h, 0 is in the place of k. The axis of symmetry will be the line x equals -3. That will be a vertical line that intersects the x-axis at 3. And does it open up or down? Well, that's negative, so it opens down. All right. So just so we're clear, from that information, we can tell that this parabola looks like this. Here's -3. That's that parabola. It has a vertex on the x-axis to the left, and it opens downwards. That's that parabola. Okay, well, I'm going to try to do 3 more problems from this set. Then I've got 2 from the bottom one. I'm still doing okay on time. We had a kind of a shorter class today, not only because we started late, but also because I needed to get something. So number 16 is 1/3 of x minus 1 squared plus 2. Once again, we are already in vertex form. A x minus h squared plus k. So we can just go ahead and say h must be -1 and k must be 2, which means that the vertex is the point minus 1, 2. The axis of symmetry is the line x equals negative 1. I'm sorry. Hold on a second. Oh, no. Oh, I already tripped myself up with the negative sign. The last couple of seconds are all a lie. H is not negative 1. H is positive 1. May coals of fire be heaped upon my head for this egregious transgression. This minus 1. No. That's positive 1. So just all of that can just burn in fire. Yeah, I did that same thing like from there, but like in reverse. All right, so and then yeah, that x should not be negative 1. That should be positive 1. Woo! Boy, it's a good thing I'm not recording this or anything. That would have been really embarrassing. Last of all, the direction of opening. That 1/3 is a fraction, but it's still positive. So we open upward. I'm going to make sure to draw a line here so these two don't run together. All right, number 17. Number 17 is y equals 5x squared minus 6. So to put this in vertex form would be to make it look like this. And it looks like a is 5. But what am I subtracting from x before I square it? Nothing. And then what am I adding here? Negative 6. So based on this, it appears that h equals 0 and k equals negative 6. Being extra careful with my negative signs now because it tripped me up last time. And that means that the vertex is the point 0, negative 6. And that means that we have an axis of symmetry, x equals 0. It's just the x-axis. I'm sorry, the y-axis. And, all right, opens up or down. That opens up. 5 is positive. Okay, last one in this little group. 18. Y equals negative 8x squared plus 3. This one's very similar to this one. It's just number x squared plus something. So we can basically just repeat everything. Here a was 5, there a is negative 8. Both of them had an h of 0. This y was, this k was negative 6. That k is positive 3. And so to put it in proper vertex form would look like this. Negative 8 x minus 0 squared plus, almost wrote plus k, plus 3. And that means that we have a vertex of 0, 3. We've got an axis of symmetry of, again, x equals 0, or the y-axis. That opens down. Okay. I just have 2 more problems to do right now. And then that will conclude this portion of the solutions. Again, I remind you, I'm going to make more solutions during E-block, and whatever I don't do then, I will do in a different time, and they'll all be posted together. So, still on page 326. Now we're looking at numbers 39 and 40. So the first one up is number 39. We have a vertex of 6, 1. And it goes through the point 5, 10. The instructions say to write an equation for the parabola with that vertex that goes through that point. Okay, so since I have a vertex, it would be very convenient to start in vertex form. And since I'm given the vertex, I'm given h and k. H equals 6, k equals 1. The only thing I don't have is a. So I can just go ahead and write this out like this. A of x minus h squared plus k. And then I can see, does this contain that point at various values for a? Let's just try it for 1. If a were equal to 1, just cover it up. Pretend it's not there. X minus 6. Well, x is 5. So let's see if it works. 5 minus 6 squared plus 1. 5 minus 6 is negative 1. Negative 1 squared is positive 1. So that equals 2. All right, so when a equals 1, that equals 2. Clearly it needs to be larger. We can actually do a little algebra here. I know that it's supposed to equal 10. So we could just write this equation. A of 5 minus 6 squared plus 1 equals 10. See? Put x in, 5 in for x, and put 10 in for y. So basically, subtract 1 from both sides. That's what we're looking for. 5 minus 6 is negative 1 squared, so the only value that works is 9. So that means the equation 9 of x minus 6 squared plus 1 has that vertex and goes through that point. I guess I should write y equals. All right, so there's the equation. Now that I've done it once kind of completely, I think I can probably be a little bit briefer with the last one, and I can fit it on this piece of paper, I'm pretty sure. So, number 40. Number 40 has a vertex negative 4, 3, and it contains the point negative 3, 6. Since I've got a vertex, I know that it's going to be something like a of x minus negative 4 plus 3. So the equation is going to have that form. We just don't know what a is yet. So let me fill in those values for x and y, then we can solve for a. Y equals a of x plus 4 squared plus k. Negative 3 plus 4 is 1. A times 1. See? Subtract 3 from both sides. There's your value for a. So that means that the final equation is y equals 3 of x plus 4 squared plus 3. When you put negative 3 in there, you get 6 out there. Okay. Well, those are just a third of the exercises. The rest of them will be elsewhere.